Good morning, students. Last class we discussed pseudo NMOS logic. So the next is dynamic CMOS logic. Okay, in dynamic CMOS logic, so this is the circuit. Here the same circuit. Look at here. Here the top is PMOS is there, and the bottom is NMOS they taken. Okay, so both are shorted and we are giving one, that is a pi. Okay, so here the logic is implemented as shown in here figure. So it has an n blocks. Okay, n blocks based on the logic to be implemented. Along with there are two more transistor is called pre-charge transistor. Here the PMOS we called as an pre-charge. Okay, so this is the pre-charge, and the bottom is called, the NMOS is called as an evaluation. Okay, so pre-charge and PMOS is called pre-charge and NMOS is called evaluation transistor. Okay, both the transistor is connected to common. So this is a common clock. Okay, so the signal is psi. We are just giving a psi. Okay, so this is the circuit. Okay, how it will be work? See, suppose if you during the pi is the clock signal is 0. Okay, suppose it is 0. Okay, that time the PMOS is on. So you already know the PMOS is drawing in 0. Okay, so that's why PMOS is on and the NMOS is off. Okay, then the pull down network is not is on state. Okay, that means the pull down state is not in on state. Okay, then the pull up output is the pull up output. So you know this is a pull up and this is a pull down. Okay, then the pull up output is pulled to VDD. Okay, the output is pulled to VDD, that is the output is pre-charged to VDD. Okay, the output is pre-charged to VDD. Okay, suppose if I am giving a clock signal 1. Okay, what happened? PMOS is off and the NMOS block will be conducting. The NMOS block is conducting as the evaluation transistor is on. So thus the load capacitor discharges depending on the input states of the N blocks. Actually here we have to connect the transistor. So but internally it is there, but they are not showing here. Okay, so the next is, so some of the problem we can see in the dynamic logic, that is, so the first problem is charge sharing. Okay, so the first one is charge sharing problem occurs if the input if the input is changes during the on period of the clock. Okay, and the second one is the single phase dynamic logic. Okay, here the single phase of dynamic logic structure cannot be cascaded, so we can't able to cascade it because of the delay. Okay, this delay may result in a wrong output result. Okay, and see here, so this is the structure, one more structure is there. So okay, so using this structure, here what we are using, so this is the transmission gate. Here we are using, so the same circuit, okay, with the PMOS and NMOS with the N block, the output is connected with the transmission gate. The output is connected with the transmission gate. So this is a type 3 arrangement. So I will explain. So here the table is there, type 1, type 2, type 3, type 4. You can use any type. So here we are designing for the type 3 arrangements. Okay, so to overcome this we are just designing this circuit. So I will explain the waveform first. So this is to overcome this problem in a dynamic logic. So these are derived from the clock must be used. So we are using the clock. So here we are using a 4 possible clocks we are using. So the clock 1, clock 2, clock 3, clock 4. Okay, actually first we have to consider the clock 1, so clock 2, clock 3, clock 4. Okay, we are just considering the 4 clocks. Okay, so I will explain how it will be work. The possibility, so this is the possible 4 clocks are derived the clocks. Okay, so the first clock, okay, if the first clock is high, okay, see, first clock is high and the remaining is till here you have to take 0. Okay, first, second, third, fourth. Okay, remember, don't consider now this clock, only you just draw from high and then 4 clock low, 1 2 3, remaining 3 clocks low. Okay, the next clock is after this clock you just make it as an high, the remaining is low, 1 2 3. Okay, make it as low. And the third clocks, whenever after the second clocks the third clocks will be on, make it as till now it is 0, after that it is 1 and again 0. And the fourth clocks, the 0 will occur after the third clocks, it is take it as an on state. Okay, after this clock, okay, after this clock, see here, after this clock, okay, after this clock, okay, so take a straight line here, this one. After this, okay, again the clock will be, the first clock will be on. Okay, the clock will be repeated same. Okay, first this clock, second this clock, third, fourth, again the first clock. Okay, understood now? Okay, the next is then the clock signal 1 2, it means you just added 1 and 2. Okay, if you added this one, this is also high, this is also high, make it as 2 high. Okay, and then the clock 2 3, 2 3 means this one and this one, make it here 2 and 3 is high. Similarly you have to do for the clock signal 3 4 and clock signal 4 1. Okay, understood the this one waveform now? Okay, so it uses 4 phase clocks, that is a pi 1, pi 2, pi 3 and pi 4. Okay, and these are derived clocks pi 1 2 and pi 2 3. So these we called as a bottom is there, no, so these we called as a derived clocks. Okay, so these are the derived clocks, so which are obtained by the overlapping the clock signal. Okay, so the circuit is modified with the inclusions of what we have included here, the transmission gate. Okay, the transmission gate samples the output during the evaluation phase, that means this phase. Okay, this is our evaluation phase and this is our pre-charge phase. In the evaluation phase, the samples output is evaluated and holds the output state until the next stage is evaluated. Okay, till now it will be waiting. Okay, it will be hold, and for each stage different phase signals are provided. Okay, each stage we will get a different phase signals are provided for the pre-charged and evaluations and also for the transmission gate. Okay, see here, so this is the summarized table. So this is a table. Suppose if you applied gate type 1, type 2, type 3, type 4. Okay, so these are the evaluations clock and this is the transmission gate clock. So in evaluation clock we are taking so the clock signal 3 4, 4 1, 1 2 and 2 3. Okay, so this is the standard table. Okay, you have to remember, and so this is the transmission gate. The transmission gate is 4 1 1 2 2 3 3 4, and finally so this is the allowable next type. Okay, so type 2 or 3, that means here 4 1 is there, rest of thing we have to take it, that is a 2 3. Similarly 1 2 is there, so the rest is 3 and 4. 2 3 is there, so 4 1 they have to allow for the next step, and 3 4 is there, 1 2 they are allow for the next step. Okay, so this you have to write this table for the dynamic CMOS logic. Okay, thank you.